Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data preparation for BI and analytics. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding the time series data and dealing with time series data. So far in the previous session, we have discussed, let's say, how to flatten the hierarchies, how the data denormalization works. So in this session, we shall be dealing with the time series data and let's say, uh, what is time series data in the first place, and then we'll be, let's say, writing queries on the same. So let's switch to the SQL. So guys, when we talk about time series, right? So time series essentially refers to sequence of data points indexed over time. So they can have, let's say, the data points can have any time denomination. All right, so we can have any time denomination. For example, let's say it could be hourly sales, all right, or maybe sales per hour for entire month, all right. Online, let's consider it online sales per hour for the entire month, right? Likewise, we can have maybe, let's say, views per month, all right. This could be views per month, this could be YouTube views per month, then this could be energy consumed per quarter, all right. So likewise, and then maybe inflation, or maybe recession or inflation factor or GDP or something. Anything of this sort can be considered as time series, right? So over here, this is, let's say, not just the data is not captured only for single timestamp, we are capturing it for the multiple timestamps. So online sales per hour for the entire month, starting from, let's say, day 1 to day 31 of the month, for each hour the data is captured online sales. What is the amount of sales generated? Likewise, YouTube views per month. So maybe for 1 year, maybe for n number of years, what is the number of views gained per month on one particular video? Then energy consumed per quarter. So per quarter, what is the energy consumed, the energy produced? All right. So likewise, this type of data is referred to as time series data. One very common example could be stock price. All right, stock price data. So it is not just captured, let's say, for any denomination. It is the data is available. So what are the time denominations? Date and time denominations for the time series data. So we can have, let's say, at the lower level, we can have second, then we can have minute, then we can have hour, then we can have day, then we can have week, then we can have month, then we can have quarter, then we can have year. These are the usual time denominations that we use for the time series data, right? So these are the usual denominations. We have second, minute, hour, day, week, month, quarter, and year. These are the usual options that we have for the time series data. Next, if we look at our data, so currently we'll be working with three tables. We have the promotion data, the sales data, and the target data, right? So these are the three tables that we are going to work with. Over here, I'm having select star from the promotion date. So promotion data. So if you observe at the promotion data, right? So we have date and region wise, date, region, product wise, quantity, the unit price, and the revenue. All right. So this is the data that we have. And if we observe the data is present from 2023-01-27 all the way up to. So for multiple dates, the data is given. So we have in total of 30 records. So it's not, let's say, data for the daily basis. There are total 30 records on different days the data was collected. And on this date, for this particular region, for this particular product, this was the quantity. And this is the corresponding unit price. And this is the total revenue, which is nothing but price into quantity. So this is how, let's say, the data is captured. So this is the promotion data. Then we have the sales data. So this is the sales generated due to promotion. Then as far as the sales data is concerned, over here we have 300 records. So we have data starting from 2023 0105, then 0108, 0109, 010, and likewise. So for each month we have n number of days of data. All right, as in for the first month, Jan of 2021, we have somewhere around 10 to 15 records, right? 10, 12 records. Likewise for the second month and so on, we have n number of records. So this is the data for 2023, and then we do have the data for 2024. So for multiple days, for multiple months, we do have the data. The region that we are considering over here is east, west, north, south. These are the four regions available. These are the four regions available. So we have east, then we have north, then we have south, and then we have west. These are the four regions. And what are the products? So we have widget A, widget B, and gadget C, gadget I think tool D. So we have these kind of products. Then the quantity, let's say, is continuous data. Unit price is also continuous, and even the revenue is continuous. So for the sales data, we have 300 records. Then for the target data, how many rows do we have? For target data, we have 60 rows. So again, the data varies from 2023-01 all the way up to 2024 1230, right? And again, we have four different regions. We have different products: widget A, widget B, widget C, and likewise, then we have the quantity. Then we have the unit price, and then the revenue, right? So this is the data that we have. So if I were to check distinct, let's say region from the sale data, or let's call it the sales data. So what do we end up getting here? We have east, west, north, south. If we were to check the distinct products from the sales data, so we have widget A, widget B, and gadget C and tool D. These are the four different products that we have. So let's calculate total revenue per month from sales data. So next, having understood the time series data, we shall be solving, let's say, problems. Will be handling the problems on time series data. Alright, so what are the problems that we shall be discussing? Let's handle them one by one. So the first problem is total revenue per month from the sales data. So over here I'm writing select year, date as year, and then month, date as month. So in this sales data, right, we have date, region, quantity. So this is quantity, again this is quantity, and this is quantity. Unit price, revenue. So from the date I can extract the year and month. So this is what I've extracted. I've extracted year function onto date to fetch the year, and then I'm extracting the month function from the date to fetch the month. And then over here I'm writing some revenue. Next I'm writing some revenue as the total revenue from the sales data, right? From the sales data, and then over here I've mentioned group by year, date, and over here I've mentioned month, date. So what is it that I'm ordering by? So I'm ordering by year and month. Over here I'm ordering it by year and month. So let's execute this. So when I've executed this, just as you can see, for each year and month we get to see the total revenue, right? For each year and month we do get to see the total revenue. Now I can compare this. This is for the from the sales data. I can compare the same sales data to the target data to the promotion data as well. All right, this is what can be done. Next, we have monthly revenue versus target. Over here, I'm going to compare monthly revenue versus the target. So monthly revenue, let's say for sales data, this is for the sales data versus target. So target will be from the target data. All right. So if it were only for year and month, then it would have been easy. Okay. So maybe that also we can compare. Even that can be compared. So over here, I'm selecting year, month. Over here I'm having year, month, then I'm writing s dot region, s dot product, then sum of revenue as total revenue. So s dot date is the sales, s dot date is the date from the sales table, and I'm converting it to year. Then let's say s dot date, I'm converting it to month, so again indicating from the sales table I've considered the date. So over here we have year and month, right? Over here we have year and month, and then over here next I'm writing s dot region, s dot product. So based on year and month, I'm also considering the region and the product. Next, based on these four columns, I'm computing the sum of revenue from the sales table. So s dot revenue, sum s dot revenue. So means sum of sales table revenue, and this is what I'm considering as the total revenue. Then sum of t dot revenue. T is the target data. From the target data, if I were to compute the revenue, so this is sum from the target table, right? Revenue of the revenue from the target data table, and then I'm summing it up. So I'm calling it the target revenue. Let's call it the target revenue from sales data S. So this is the left table, and then I'm joining it with the right table. So what is my right table? My right table is target data. So what are the columns on which I need to join? So I have to join it on three columns. First, I'm joining it on s dot date is equal to t dot date. So the date matches. All right, so maybe there is no exact match on the date, right? Maybe there is no exact match on the date, or maybe a couple of dates may vary. So and s dot region is equal to t dot region, and s dot product is equal to t dot product. So where the region matches and well as the product also matches. So sales dot region matches target region, and sales product matches the target product. And then I'm grouping it by year, month, region, and the product. So maybe we may not have more than let's say 5-6 records. Let's see, I'm only getting one. What is the reason? Because for only one region there is a match in the date, and maybe there's a match in the region and the product. So what can be done over here? I can mention, let's say, year of S date matches year of T date, and let's say month of S date matches month of T date. Alright, so next I'm considering this. Now we should end up getting more results, hoping. Yeah, so as you can see, so the okay, for year, and let's sort it by year and month. So this would be order by year and month. This should generate the desirable result. So for 2023, for first month for the East region for the project gadget, the total revenue is this, and the target revenue was 2579. So of course, it was overachieved. For 2023, for the first month for the East region for widget B, 2168 was the total revenue. The target was 8526, so it was not achieved. For 2023 third month West Tool D, this is the total revenue. This is the target revenue. So of course, so the total revenue does not exceed the target revenue. Alright, so likewise for 2023 we have the data from for these months 1, 3, 4, 6, 7. Maybe for multiple regions means there are a month is repeating, and then let's say for 2023 then this is the data that we have, and for 2024 we have 1, 2, 3, and then 5, 6, 7, 8, 9, and 10 and 12. So for both the years, for multiple months we do have this data. So from the same data, we can figure out the year and month and maybe the region and the product where the total revenue exceeds the target revenue, right? So one obvious challenge in the industries, let's say in the businesses, is to achieve the target. So maybe we can compare in which months, in which region, for which product, and for which year, let's say the target has been achieved. Next, maybe I need to compute the YOY revenue growth. YOY is nothing but year on year. Year on year, what is the revenue growth? So how can I extract this? Over here I'm writing like this. So this utilizes something referred to as the window function. So I'll explain while solving. So over here I'm having region and product, and year. So I'm considering date as the year, some revenue as the yearly revenue from the sales data, right, from the sales table, revenue growth for the sales data. So this is what we have, and over here I'm writing lag sum revenue over partition, partition by region, product, order by year as the last year revenue. So this is what we have as the last year revenue. So lag returns previous value. All right. So sum of revenue, because we have this column, so I'm applying lag. So this returns one previous cell value. All right. So this is lag. By default, the lag order is 1. So over partition by, I'm partitioning it by region, product, and the year. Alright, so region, product, I'm partitioning by region and product, and order by year as the last year revenue. So this would be the last year revenue because I'm ordering it by year. So this is the last year revenue. So if I were to just execute this, I'll show you what is the result, the intermediate result. So let's get rid of the comma. Let's run this. So see, this is yearly revenue and this is the last year revenue. Alright, so every time the year is changed, the last year revenue is not available. Alright, so because we are applying it on let's say region and product, so the last year revenue is not available. Alright, but this data is available. Alright, because over here the product, whenever the product changes, the last year revenue is not available, but this data is available. So because we are computing it based on let's say region and product as well, that is why we are getting this kind of result. So once this is done, then we have sum of revenue, means current value minus the lag value. So sum of revenue minus lag sum revenue over partition by region, and then over here I'm writing product order by year date. All right, and then I'm dividing it by lag sum revenue. So because I need to find YOY year on year revenue growth, so this is the growth in percentage change. So current value minus previous value upon previous value is the percentage change. So again I'm dividing it by lag sum revenue over partition by region, and product order by year. So I'm multiplying it by 100, so to represent YOY percentage growth. All right, so this is my YOY growth percentage from the sales data, grow by region, product, and year date. So let's run this. So when I'm executing this, what we can see the percentage change over here is negative. Over here the percentage change is negative. Maybe if I were to write this in subquery, this would be much better. So let's write this in the subquery, right? So maybe this is where we have the lag. This is the lag, right? So once I have this, let me store this in the subquery. So over here I can write select star from, and then I'll call this dt. So after star, then I'll write, so this is yearly revenue minus last year revenue. All right, yearly revenue minus the last year revenue upon last year revenue upon the last year revenue. So this is the YOY as YOY growth. And because this output may be in fractions, so maybe I can round this off up to 2 digits. So I'll be rounding it up to 2 digits, right? So this is where I'm writing the round function, and as YOY growth. So this is yearly revenue. Okay, 2 brackets are not needed. Yes, so this is yearly revenue minus last year revenue. Okay, another pair of bracket would be needed. So this is just this part, and yes, so now this there would be no fractions, means only up to 2 digits. So region is not present. Okay, I need to apply group by. So in the subquery over here, I need to apply group by, and that's it. Let's run this. So unknown column region in the field, region product year. So I'm considering everything, and once we have this, okay, so group by region product and year. So once we have this group by would go outside this query, and then I'm grouping by this. Let's run this. So again, unknown column region. So where is the region going wrong? Unknown column region. Okay, let me run just this part. So if I were to execute this part, so unknown column region. Okay, so here the region is generating some issue. So region product from sales data, right? Okay, from sales data I forgot to mention, so this would be from sales data, and then this grouping. So now the output is returned, right? So from this output, now from this output on this output rather, so from the sales data I just need to I'll be writing this in dt, and then this would be then I can write this part. So now if I were to execute this unknown column date in the group statement, okay, there is some error. Let's check this. Okay, no issues. Let's continue with what we have, right? Let's continue with the current result. So this is what we have, and this is how we have implemented it. So next we want to find a month where sales is above 20% of the target. All right. So month where sales is sales from where, sales or rather revenue. So over here when I'm talking about revenue from the sales data. So from the sales data, this is 20% above the target revenue. So how can I capture this? To capture this, what can be done? Select s dot say s dot date, s dot region, s dot product, s dot revenue, and then I'm having t dot revenue from sales data join target data on year of s dot date is equal to year of t dot date, right? And then I'm having month wise s dot date is equal to year of t dot date. All right, and then I'm also combining it based on the region and the product, and let's see if the revenue is less than let's say revenue is maybe greater than 1.2 times the target revenue. Let's run this. So currently there is no data, so maybe let's exclude this and check. We'll change the question. So okay, again no data. So where the date matches with this date and month also matches, right? and even the region and the product matches. Okay, so because I'm passing date, let's pass year and month. Year and month of s dot date. Now let's check this. So no data again. Strange. Let's see. This is a month where revenue from the sales data is 20% above the target revenue. So we have this data, right? This is the data. This is the data that we have now. Over here we are comparing the total revenue and the target revenue. So this is where we need to filter the total revenue and the target revenue. So let's check this. So this is what we have. Next we just need to filter. So what is the filtering condition? So I've applied group by, where what is my filtering condition? The filtering condition is total revenue. Okay, so because I've applied the group by, so I have to apply having total revenue greater than 1.2 times the target revenue. So now this should work. Let's see. So guys, these are the records. Total revenue is 20% more than the target revenue, right? So clearly currently the values comply the same. So we have 11 records in total. So this is how we have implemented it. Next, I want to find average daily revenue per region. So over here I'm writing, and this is from the sales data. So what are we writing over here? I'm writing select date, region, average revenue as average daily revenue from the sales data group by date, region. So guys, this is the date, this is the region, and this is the average daily revenue. This is the average daily revenue that we have. Next, over here I'm computing product wise highest revenue trend over time. So over here I'm writing select year date as year, then I'm writing month date as month, then over here I'm writing the product sum revenue as the monthly revenue from the sales data group by year, month and product, and order by monthly revenue in the descending order. So guys, this is the product wise highest revenue trend over time. So for the product D, the highest monthly revenue is this. So maybe the sum revenue I can round it up to 2 digits, because it's a very let's say the data does not seem to have, yes, now it's much better. So let's observe the query and the output. So the query that I'm having is this, right? So select year, then date as year, month, date, product round sum as monthly revenue from the sales data group by year, month, product, and order by monthly revenue. So this is what we have implemented. Next, I want to find the days with the highest promotion impact. So for the promotion means, let's say, so I have to compute for the promotion data. It has to be computed for the promotion data, right? So how do we compute this? Over here I'm writing select s dot date. So this is from the sales data, means we need to come days with highest promotion, right? So we'll be comparing the sales data and the promotion data. So over here I'm going to compare sales data with the promotion data. And for the revenue, I'll be comparing them both. So select s dot date, so date table from the sales column, sales data column, then s dot region, s dot product, s dot revenue. So from the sales data table, I'm let's say incorporating the date, region, product, and the revenue from the sales data S, and then I'm considering the promotion data P. What is the joining condition? The joining condition is where s dot date is same as the P dot date, means sales date and product date is same, and s dot region is same as the P dot region. So where the sales region and the product region is same. And then next I'm computing s dot product is same as the P dot product and order by s dot revenue in the descending order. So there might not be multiple records, maybe just one or two. So over here I'm getting one. Why? Because over here we have only considered the exact date match, right? So exact date match may not be many. So what if I only compare the year? Let's see, if I were to compare the year, now what am I getting? I'm getting these records. Alright, so I'm getting these records. Currently I'm only comparing with the let's say revenue from the sales table, right? I'm only comparing the revenue from the sales table. So days with let's say highest promotion impact. So because I've applied it on let's say this table, so maybe I can compute the sum. Alright, so this is year, let's call it year, and then we have month, so s dot date, this would be month. So this would be sum of revenue as the total revenue, from sales data F on promotion data P. So where not only the year matches but the month matches as well. So the month should be matching as well. Alright, so I need to figure out the month where they are matching. And this is the join region and the product and order by revenue. So let's run this. So order by revenue descending. So okay, so I have to mention group by, right? So group by year, month, region and product. Year, month, then I need to pass the region and the product. So I have incorporated the revenue from the product table, right? So order by S dot revenue. Okay, so it won't be S by revenue, now it would be total revenue. So guys, this is the result that I'm getting. So this is the total revenue from the sales table, right? Now I can also compute, because I have to compare it from the promotion impact. So I'll be comparing S dot P dot revenue, and this is the promotion revenue as promotion revenue. This is where we are comparing both the sales. I'm comparing both the revenues. So guys, this is the total revenue, this is the revenue from the promotion. So if need be, we can round them up just to make the result visually more meaningful. Alright, so I've rounded it up to 2 decimal places, and this is the result that we have, total revenue and the promotion revenue. Let's proceed to the next question. So in the next question, I have to split time into year, quarter, month and week, and this is for the sales data. I have to apply this for the sales data. So this is the easiest question. Over here I'm writing select date, and then let's say year date as year, then I'm considering the quarter, then I'm considering the month, and next I'm considering the week as well. All right, from the sales data. So this is what we have: year, date, year, quarter, month and week. So we have extracted all the details for all the dates. So we have 300 rows of data. Next we have, I want to find cumulative revenue month to date, and this is from the sales data, right? So this is from the sales data. So how can we compute this? Over here I'm writing select region, product, date, and then sum revenue over. So partition by, I'm using region and then the product. So over here I'm using year and month. So when I'm using so over here I'm using sum as a window function. So sum revenue over, because I need to compute it cumulatively, right? So sum over partition by region and product, and then again I'm considering the year and month. So I'm ordering it by date as MTD, month to date revenue. This is going to be my month to date revenue. So this entire column, this entire calculated column would be my month to date revenue from the sales data. So region and product wise MTD revenue. So this is region, product and date wise MTD revenue that we are capturing over here. So this is cumulatively. This is working entirely cumulatively. All right. So it is cumulative over region, product and year. So for region, product and year of date, this is cumulative, year and month, right? For region, product, year and month, it is cumulative, and then I'm ordering it by date. So on a single date, if there are multiple records, only then it will move to the next. So next we have rank products by monthly revenue per region. This is the next question. So over here I'm considering select region, and then we have year date. Alright, again we'll be using the window function. So over here, let's say I'm selecting region and then year date as year. Then I'm using month date as month. Product from the sales table. Then sum revenue as the total revenue. All right, and then rank. So I'm using the window function. What is the general syntax for the window function? The general syntax that we have is let's say the function name. Then we have to pass partition by some column, and then order by some column. It could be ascending or descending. All right, this is the general syntax of the window function, and then some alias name, then maybe the column name that I want to provide to the window function. So this is partition by, so means the function name will be grouped by this column and order by with some other column. So order by can be in ascending or descending. So over here I'm writing select let's say region, year as year, and then month date as month, product sum revenue as the total revenue, rank over partition by region, year date month, order by sum, sum revenue descending as the month rank, right? So I'm partitioning it by region, year and month, and ordering it by the sum of revenue which we have computed over here. And then from the sales data, so it has to be grouped based on let's say region, year, month and product. So let's see. So let's say for each month, right, for each year, for each month, I'm getting the ranks 1, 2, 3. Next, for the second month, again, I'm getting the ranks 1, 2, 3. So this is essentially month-wise rank, right? So the last one is what I'll be using, means partition by region, year and month. So for each region, for each year and for each month, I'll be getting the ranks 1, 2, 3 and so on. So guys, we have a total of 212 records. Alright, so this is the result. Next, we can look for a simple, let's say, forecast. So this is linear growth project for the next month. So over here I've utilized a concept called CTE, which is referred to as common table expression. So over here I'm writing with monthly sales as select year. Then this is it's not the sale date, it's the date. Then the date, and then sum revenue as the monthly from the sales. This is nothing, this is not the sales but the sales data, and I'm grouping it by year and month. So this query should work in isolation as well. Let's see this. So this is the query that I want to run. Let's see if it's working. And yes, it's working, right? So this is the first part that I'm integrating it in monthly sales. So this is nothing but my year and month by sales. So this is, I'm simply calling it the monthly sales. So this is the first part. So I'm wrapping it in a CTE. All right, means common table expression which I can use intermittently. So I don't need to write this table again. I'll be using it intermittently. So this I'm storing it in the CTE, and how to use the CTE over here I can write select CTE 1. That's it. So now this is the result. Select star from CTE. So this is acting as a common table. So it won't be available after the query has been executed, right? So it loses the context. So this is the monthly sales. Then next I'm computing the growth. So this is another CTE. So the second CTE that I'm using over here is maybe let's call it the CTE2. So I'm calling it let's say CTE2, CTE2 as. So over here I'm using month and then the monthly revenue, then I'm considering the lag, all right, from the monthly sales. So over here I'm storing the lag, all right. So maybe if I display select seat star from CTE2, so this will only display the lag part. Order by year, month, previous revenue from the monthly sales. So monthly sales we don't have, we have CTE1. Alright, so now if I execute this, this is monthly revenue and this is the previous revenue. So maybe I just need to use round function over here and even round function over here. So this would automatically, this should be rounded, yes, and we are getting the correct results. So these two CTEs are done. Then over here, next what I'm computing, I'm simply computing this. I'm simply trying to figure out the difference between these two, right? So over here, instead of from CTE2, what I'm writing, select average of monthly revenue, which is over here, and the previous month revenue, right, as average growth. So because this information is already available over here, so I can use maybe not CTE2. So select average monthly revenue minus previous revenue as the average growth from the CTE2. This is the CTE2 which I've used, and where previous revenue is not null. So this is how I can compute the forecast for the next month. So the average forecast for the next month, and because I'm getting negative values, so let's translate this to absolute. Let's convert it into absolute so I don't get negative value. So guys, this is what I'm getting. This is the average growth which I have obtained, right? So this can be used as the forecast. Means a naive approach, but still let's say to explain the non-technical stakeholders, this is one approach that can be utilized. So guys, that brings us to the end of this session. Let's switch to the PPT. So guys, in this session we have understood the time series data and we have handled queries on the time series data. In the next session we'll be moving to the query reporting, and we'll be working on end-to-end project on SQL and Power Query Excel. Thank you.